There we go, that's better. So this is going to go over syslog servers and SNMP traps and a lot of the things that we've talked about previously, and Cisco's integration of their log files into that whole management scheme. We'll also talk about updating the iOS, which we've done previously. Why isn't it changing? Ah, okay. So we'll talk about CDP, LLDP, NTP, SNMP, syslog, some of our router and switch file maintenance, and your iOS management. All very important things for you to know as systems administrators. Absolutely. So these are some of the things we're going to be going over. Device discovery with CDP, that's your Cisco discovery protocol. And the device is basically going to send periodic advertisements to connected devices. It is Cisco proprietary. The advertisements share information about the type of the device that's discovered, the name of the device, and the number and types of interfaces. For Cisco devices, it is enabled by default. So you need to make sure that if you want a more secure environment, that you have it disabled. Also, don't forget, you're going to want to make sure that you disable it on your edge interfaces, because you do not want to be advertising your internal network information to your ISP. As I said, it's enabled by default. To verify the status of it and display information, you can do show CDP. To disable CDP on a specific interface, you're going to enter no CDP enable in the interface configuration mode. CDP is still enabled on the device, however. So no more CDP advertisements will be sent out that interface, but all the other interfaces it will. To enable CDP on the interface again, enter CDP enable in that interface configuration. To enable it globally for all the supported interfaces on the device, you'd enter CDP run in the global config mode. CDP can also be disabled for all of the interfaces on the device with the no CDP run command in global config mode. You can use show CDP interface command to display the interfaces that are, excuse me, that are CDP enabled on a device, and the status of each interface is also displayed. So as far as your own network troubleshooting and management, CDP is a great tool if you're using all Cisco devices. I also suggest that no network be one vendor specific, because that can leave you open to exploits on that one specific vendor's device. So to discover our neighbors, we can use CDP, and this output is showing that there's another Cisco device, switch 1, that's connected to G00 on router 1. And it's also showing that switch 1 is connected through its F05 interface. So there is a lot of really good information that you can gather from this. As we can see here, the address for S1 is 192.168.1.2. So our show CDP neighbors detail. So device discovery with LLDP. As I said, I would consider it best practices to not use Cisco across the board, to have other vendors integrated with your system, with your network. So, and if that's the case, you're going to be using the Open LLDP protocol. And it works with network devices like routers and switches and wireless LAN points. It advertises its identity and capabilities to other devices. It also receives that information from physically connected layer 2 devices. LLDP may be enabled by default depending upon the vendor. To enable LLDP globally on a network device, on a Cisco network device, you're going to enter LLDP run in global config mode. To disable it, no LLDP run in global config mode. You can also configure it on a specific interface. However, LLDP must be configured separately to transmit and receive LLDP packets. So to verify that it's enabled, you can enter show LLDP in privileged exec mode. Here we're enabling LLDP on G01 to transmit and receive information from the neighboring devices. And notice that we have to specifically or explicitly state transmit and receive. For our show LLDP neighbors, your neighbors can be discovered when you're using that, and we can see what's connected. So we have router 1 through F05. It has a 117 hold time. We've got switch 2 on F01 with a 112 millisecond hold time, and the ports that are attached to it. So when more details about the neighbors are needed, you can do a show LLDP neighbors detail, and then you can really get a lot of information like the neighbor's iOS version, IP address, and device capabilities. So anybody see any problems with this? So I would consider security an issue because you're saying exactly what software release you're using. So somebody could easily pull that up and see what exploits are available and what vulnerabilities it might have, and then proceed to take over. So with these tools, they're good management tools for you, but I'm going to include the caveat that it is really important to consider security when you're thinking about all of this, because it's very important. Network time protocol. So it's really important that we have our time synchronized. Typically, we can set the time and date settings on your router or switch. You can either do it manually or you can use network time protocol. As the network grows, it's going to become difficult to ensure that all of the devices are operating with synchronized time if you're doing it manually. So if you use network time protocol, it's going to allow the routers on the network to synchronize their time settings with an NTP server. That's going to provide more consistent time settings. It's going to be set up to synchronize with a private master clock, or it can synchronize to a publicly available NTP server on the internet. NTP is going to use UDP port 123, and if you are an insomniac and you need some good sleep material, you can read its documentation in the RFC 1305. So it has a hierarchical system of time sources, and the stratum level is defined as the number of hop counts from the authoritative source. So synchronized time is distributed across the network using NTP. The maximum hop count is 15. Stratum 16 is the lowest stratum level, and that indicates that a device is unsynchronized. And don't forget, as we're going through these hops, we're going to be losing time, which is why level 16, the lowest level, is unsynchronized. So with our operation, we have stratum 1, and that's the authoritative time source. Stratum 0, that's the authoritative time source. Stratum 1 are the devices that are connected next to the authoritative time sources. And then we have stratum 2 or lower, and it just depends on what layer of the hierarchy that you sit. So we can set time servers on the same stratum level as peers with other time servers on that stratum level for verification. So the NTP server IP address command is issued in global configuration mode. So in order to configure 209.165.200.225 as the NTP server for router 1, This is the way we would do it. It would just be NTP server and then the IP address, and then end. We can use show clock detail command, and then we can see that the time source is now NTP, as opposed to manually configuring it. Notice that router 1 is synchronized with stratum 1 server at 209.165, 200, 225, which is synchronized with the GPS clock. So show NTP status displays that router 1 is now a stratum 2 device that's synchronized with NTP server at 209, 165, 220, 220, 225. So here we've got the stratum right there, stratum 1 by GPS and stratum 2. And the output from show NTP associations is going to show you that the clock on S1 is now synchronized with router 1 at 192.168.11 via NTP. Router 1 is a stratum 2 device, making switch 1 a layer 3 device, a stratum 3 device, sorry, oops. And that can provide NTP services to other devices on the network. And let's see, so SMTP, Simple Network Management Protocol. Excuse me. It's a really important tool. It helps administrators manage their nodes on the network. And SNMP defines how management information is exchanged between the network management applications and the management agents. So the manager polls the agents and queries the MIP for SNMP agents on UDP port 161. SNMP agents send any SNMP traps to the SNMP manager on UDP port 162. So please remember that UDP ports 161 and 162 are the operative ports for this management tool. SNMP agents can forward information directly to the manager by using traps. The SNMP agent and the MIB reside on the SNMP client devices. The MIBs store data about the device and operational statistics, and they're meant to be available to authenticated remote users. The SNMP agent is responsible for providing access to the local MIB. Excuse me. So the operation, we've got get request, get next request. The agents that reside on the managed devices are going to collect and store information about the device and its operations locally in the MIB. And the SNMP manager then uses the SNMP agent to access the information within the MIB. There are two primary SNMP manager requests. We've got get and set. In addition to this configuration, a set can cause an action to occur, for example, starting a router. And get, so we can do a get MIB variable, and that the SNMP agent is going to perform this function in response to a get request PDU from the network manager. The agent's going to retrieve the value of the requested MIB variable and then respond to the network manager with that variable. Set an MIB variable, so the SNMP agent is going to perform this function in response to a set request PDU from the network manager. So the agent is going to change the value of the MIB variable to the value specified by the network manager, and an agent can reply to a set request would include the new settings in the device. So something to think about is traps. They are unsolicited messages that alert the SNMP manager of events and conditions. And here we're looking at the use of an SNMP trap to alert the administrator that interface G00 has failed. The NMS software can send the network administrator a text message or pop up a window in the NMS software, or turn the router icon red in the NMS GUI. So there are a number of different possibilities available to alert you to a specific problem. So let's talk about SNMP and some of the versions and some of the shortcomings of those versions. So SNMP depends on secure settings or community strings that grant access to portions of devices management planes. And abuse of the SNMP could allow another unauthorized third party to gain access to the network device. SNMP version 3 should be the only version of SNMP that you use, because SNMP v3 has the ability to authenticate and encrypt their payloads, where SNMP v1 and v2 are employed. A bad guy could sniff the network traffic, determine the community string, and then that compromise could lead to a man-in-the-middle attack or a replay attack. So although SNMP v1 and v2 have similar characteristics, a 64-bit counter was added to SNMP v2 so it could support faster interfaces, and SNMP v3 replaces the simple clear text password sharing used in SNMP v2 with more securely encoded parameters. All of these versions are going to run over a UDP. SNMP depends on secure strings or community strings that grant access. Oh, sorry, I already said that. One of the things you want to think about is with SNMP v3, it's only going to be as strong as the encryption algorithm that you're using. So we already know that SHA-1 is broken. We already know DES is garbage. So I would strongly suggest that you use triple DES or AES. AES probably would be preferable. Don't forget, you also want to consider following the principle of least privilege. So you want role separation between polling and receiving traps. So reading and configuring users or groups writing is imperative, because many SNMP managers require login credentials to be stored on the disk in order to receive the traps. So you don't want the same login credentials for both on the same disk. You can apply extended access control lists and ACLs to block unauthorized computers from accessing the device. So access to the device with read and or write SNMP permission should be strictly controlled. Other things you're going to want to consider is segregating your SNMP traffic into a separate management network. So your management network traffic should be out of band. In other words, it shouldn't be available to all the rest of your stuff. If the device management has to coincide with your standard network activity, all the communication over that network should use some sort of encryption capability. If the network device has a dedicated management port, it should be the sole link for services like SNMP or Secure Shell or whatever, SSH. Yeah, so with utilizing this wonderful tool, we need to make sure that we secure it so that we have a comfortable, secure environment. And so here we've got an explanation of our community strings, and you don't want to use SNMP v1 or v2, so please don't. To view or set the MIB variables, the user has to specify the appropriate community string for read or write access. And the MIB tree for any given device includes some branches with variables common to many networking devices, and some branches with variables specific to that device or vendor. So RFCs will define some common public variables. Most devices implement these MIB variables. In addition, networking equipment vendors like Cisco can define their own private branches of the tree to accommodate new variables specific to their devices. And so here we have, this is showing portions of the MIB structure defined by Cisco. Note how the object ID can be described in words or numbers to help locate a particular variable in the tree. And for a polling scenario, basically the data is retrieved via the SNMP GET utility, and that would be issued on the NMS. Using the SNMP GET utility, you can manually retrieve real-time data, or you can have the NMS run a report. The report would give you a period of time that you could use the data to get the average. So depending upon what network management system you're using will give you more or less features, but they will all be going by pretty much the same syslog, or the same standard language, for lack of a better term. So the object navigator, so we could use, Cisco has the SNMP navigator, but of course there's SolarWinds and all those other wonderful companies out there. Splunk, just lots of great tools out there. You can use the SNMP GET utility for some insight into the basic mechanics of how your SNMP works. If you're working with long MIB variable names like 1, 3, 6, 1, 4, 1, 9, 2, 5, it can be a real pain for the average user, right? Frequently, the network operations staff is going to use network management product with an easy-to-use GUI, which makes the entire MIB data variable naming transparent to the user. So you don't have to worry about that as much. You're just going to have a management tool. Syslog, yay, we love our log files, right? So Syslog logging service provides 3 specific functions. It gathers logging information for monitoring and troubleshooting. It gives you the ability to select the type of logging information that's captured, and it gives you the ability to specify the destinations of captured syslog messages. And if you have half a brain, you're going to have all of those syslog files sent to your syslog server. So all of your log files from all of your devices will be going to one server. The network administrator could specify only certain types of system messages are sent to various destinations, because you don't want all of the information, right? You don't want every single little bit of information. You want specific error codes. You want specific problems. So some of the popular destinations for syslog messages would be your logging buffers. That would be your RAM inside of your router or switch. It could be your console line or your terminal line so that you're seeing it on your screen, or it could be going to the syslog server. It could be going to multiple places. That would be the smart thing for sure. And we have different severity names and levels. Cisco devices produce syslog messages as a result of any network events. So every syslog message is going to contain a severity level and a facility. The smaller numerical messages are the more critical syslog alarms. If you have everything set to level 6, your logs are going to be so full of just basic information that you really don't need to know. So you really want to, if you're going to narrow it down, that needle in a haystack of what's going on, and get your proper notifications for when there is a warning or something that's significant or something that is error or critical, you really want to make sure that you set these severity levels. The severity level of the messages can be set to control where each type of message is displayed. So it could be on the console or other destinations. And so this is showing your complete list of syslog levels. So common syslog message facilities reported on Cisco iOS routers include the IP address, the OSPF protocol, sys operation system, IP security, so interface IP, So lots of good information. So you need to keep on track of things. So here, for example, the civility is link and the severity level. So the severity is link. Excuse me. The facility is link. The severity level is 3, and it's got a mnemonic of up down. So we can see that it changed its state. And for some dumb reason, by default, log messages are not timestamped on our Cisco devices. Yeah, that, I have a problem with that. You definitely want to make sure that all of your log messages should be timestamped so that when they're sent to another destination, like a syslog server, there's a record of when the message was generated. Using the service timestamps log date time to force logging events to display the date and time. Please, oh please, you've got to have your timestamps. Otherwise, you don't know. You don't. How are you going to filter events? Other than severity, you can't see a big picture of your network if you don't have timestamps on everything. So basic maintenance. Our router file systems, you're going to see this is very similar to Linux. It is probably a version of Linux. The administrator can navigate the directory structure of the IFS. It can also create subdirectories in the flash memory or on a disk. The directories available depend on the device. And so right here, it's displaying the output of the show file systems. And it's listing all of the available file systems on a Cisco 4221 router. The asterisk right here is indicating the current file system, and the pound sign is indicating a bootable disk. So both of these are assigned to the flash file system by default. And you're going to navigate around here very simply, the same way you would in any other, command line file system structure. Because Flash is the default file system, if we issue the dir command, it's going to list the content of Flash. Of specific interest is that last listing, and that is the name of the current Cisco iOS image that's running in RAM. So that way you can tell right here which image is running in RAM. And you can also see how many bytes are free, so that if you're planning on updating that image, number one, you can see whether or not the new image is going to be able to fit in there side by side because you have enough free space, or if you're going to have to delete the old image to update a new one. And I think I'm getting ahead of myself because that's down the road here. So you're just using basic Linux commands to navigate, cd to change directory, pwd for present working directory, and dir or ls to enumerate the contents of NVRAM. Here, the most important configuration file is the startup config file. And the command used to show file systems on a Catalyst switch is the same as on a router, yay, and it's show file systems. And so we can, so this is showing you how to back up your configuration files using TerraTerm. The steps backing it up to PuTTY are very similar. You're basically just saving, you're copying and saving it, which is a little bit easier than doing it through TerraTerm. So if you're copying up your configuration, it's a great idea, right? One of the things you're going to want to remember is you want to restore your non-command messages like more, and you want to make sure that you add enable and config T when you copy and paste it in PuTTY. The text in the file is going to be applied as commands in the CLI, and then it's going to become the running configuration on the device. So here are the steps to back up or restore using TFTP. And TFTP is simply not a standalone server. You can just set it up on any device as an application. It's really quite lightweight because it's a trivial file transfer protocol. We can also use USB to copy the configurations or iOS files. And we're going to use the dir command to view the contents of the USB flash and do it that way. So when we're using USB to back up and restore configuration, we're going to select Show File System to confirm the name of the USB device, and then show the name of the USB device and view it. And then we can do a copy run USB flash 0 to copy the running configuration to USB. You guys still awake? And a lot of this we did last semester, remember? So restore the configurations using a USB flash drive. It might be necessary to edit the USB router 1 config file with a text editor. So use dir command to see which files are on the USB drive, and then use more to see the contents of that. To restore a copy, you can do a copy USB flash 0 with a colon / router 1 config, or whatever your router's name, the router file name is, and then running config. And passwords. Password recovery procedures are really important, and we've used this frequently in class, or I've used this frequently in class because sometimes people fat finger their Cisco or their class passwords. This does not work on Packet Tracer. So if you're doing your case study, your practical final, I would strongly suggest that you don't enable encryption on your passwords until you are absolutely positively done. And that way, that will not be a problem, because if you forget the password on one of your devices in Packet Tracer, you just have to start all over again with that device. That whole device needs to be reconfigured, which is a problem. If you were smart and you saved the Packet Tracer PKA file frequently and with different version numbers, then you can revert to a previous version before you change the password. Yeah, so it doesn't work in Packet Tracer. So from the console, you're going to access ROM-MON mode by interrupting the boot sequence or using a break sequence during the boot process. Or you could remove the external flash memory when the device is powered off. That would definitely do it. After setting the configuration register to hexadecimal 2142, you're going to type reset and restart the device. Enter the break sequence when the device is rebooting and decompressing the iOS, so you know when it's got all of those asterisks and it's trying to load. And this is showing the terminal output of a 1941 router in ROM-MON mode after using a break sequence. So it basically gives you very little stuff to work with. You can do a copy run start to the running config. You don't want to enter copy run. So you're going to copy this correction. You're going to copy the startup config. I need to make sure that I make that. Yeah, sorry. So you're going to want to copy the startup configuration to the running configuration. After the device is finished reloading, then you're going to do a copy run start or copy start run. And because you don't want to do a copy run start, because then that's going to erase your original startup configuration. To change the password, you're going to be in privileged exec mode, and then you can configure the passwords. Do not use Cisco as the password. The password Cisco or class is not a strong password. We're only using it as an example. You know that. We
We're
can
not supposed to have
save the right
password as our
config
password?
if you startup config. And once everything's reset, you can copy run start and save it, and then you're going to revert to the 2102 register. Did somebody have something to say? Questions?
Oh, you're just like, oh yeah, strong password, and then we used all the examples from class that we use.
Yeah.
Password
Well,
of
I
the
mean,
symbols, password one.
that's the
Yeah.
default for our Cisco lab. So my gosh,
The,
you know, also please don't ever use any of the passwords that we use in the server class or in any of the other classes on your real stuff, because, oh gosh, yeah, don't do that. So image management. So there's a great video on managing your iOS images, and please watch that. And we're going to talk about using the FTP servers, the TFTP server as a backup location. So if you have lots of widely distributed routers and they need a source or backup location for their iOS software images, because sometimes they do get corrupt, you can use a network TFTP server, and that'll allow the image and configuration uploads and downloads over the network. The network TFTP server could be another router, a workstation, or a host system. It really doesn't matter as long as everything can access it. With regard to how you're going to do it, you absolutely always want to ping the server to be sure that you can reach it. You're going to do a show /0 to see the size of the iOS file. And then you're going to copy source URL to destination URL. So copying it to the TFTP server. When you are copying it to the device, you're also going to ping it. When you're updating the iOS, as I said before, you really need to check the amount of free space in Flash, because if you don't have enough space in Flash for the new iOS, it's going to fail, and that's going to be a problem. So you want to make sure that you can fit the new iOS along with the old iOS file, or you can delete the old iOS file, and there will still be enough of a microcode on your device to copy the new iOS file. But yeah, if Flash space is limited, you may need to remove the old iOS before copying the new one. And this is similar to changing the boot sequence on your BIOS, right? You're telling it to boot to and load the new iOS image. And once it's up and running, you can do a copy run start to save the configuration. Now, if you remove the old iOS and install a new one, you don't have to specify what it's going to boot to, because if you don't have any boot system commands and there's only one Cisco iOS image in flash memory, that's what it's going to run. So you only need to worry about the boot system if you have two iOSs stored in flash. So we went over Cisco Discovery Protocol, Layer 2 protocol, and it's Cisco proprietary. It can be used as a network discovery tool, and it can also easily be used by bad guys for reconnaissance to gain access to all of the things on your network that are Cisco devices. We can also use link layer discovery protocol if you're using multiple vendors for your networking devices. That would probably be the best thing for you to use, because that's the open source vendor neutral discovery protocol, and it's very similar to Cisco Discovery Protocol. And you need to, when you're doing LLDP, you need to make sure that you are transmitting and receiving, whereas with CDP, you don't have to do that. You want to set up your time synchronization, because it's really important that you have correct time across your network. And you can either use yeah, so set up your time server, and your NTP clients and all of that to make sure that you've got the correct time. And don't forget, by default, time stamping is off in your file, in your Cisco devices. So make sure that you enable time stamping. It's just so dumb that that's off by default, but it is. Um, so once you've verified you've got the correct time, you can show NTP associations and the status to make sure that it's synchronized. Your SNMP, never use version 1 or 2. Make sure that you're using SNMP version 3 and you're using a strong encryption algorithm like AES. The MIB for your SNMP is going to organize your variables hierarchically. And so you're going to have different, so you want to make sure that your objects are managed properly. And syslog protocol uses UDP port 514. So there were lots of UDP ports that we need to make sure are enabled and configured and open. Our logging services, we're gathering information. For monitoring, we're troubleshooting. And we want to make sure that we send all of our log files to a specific syslog server so that we can manage them and maintain them properly. Once again, another reason why you want to make sure that you have time stamping on it so that you can see what's going on across your network just by seeing what time things happened. Once again, what I should say is anytime a network has been infiltrated and exploited, that person has been in there and done reconnaissance, from 1 to 6 months or longer. They've been looking around and actively seeking ways to access the network. So it's a good idea to get comfortable with your log files and your syslog server so that you can see if you don't know, it's like baselining. If you don't know what is normal, then you aren't going to recognize what is an anomaly. Common syslog messages, they can be either on your screen or your console or sent to the log file or all three. You can be notified when specific event levels are reached, which is a good idea. And Cisco iOS, of course, in order to make sure that things are well patched and secure, we need to make sure that we update our iOS as needed. And so that is also another wonderfully important thing to keep on track of. And our config files, we can save it to a text file using PuTTY or TerraTerm. We can copy our file and paste it directly into the device. And you guys can copy and paste in your packet tracer too. You just need to make sure that you're getting rid of all of the non-command functions like more and that kind of stuff, and make sure that you add your enable, config T, etc. to the devices. Your iOS image, you need to make sure that the iOS image is the correct one for the platform and the features and the software, because remember there's a bunch of there's a base iOS image and then there's security, and so you need to make sure that you have your licensing and all that other squared away as well. Download the file from Cisco and transfer it to the TFTP server. And when you're upgrading the iOS image, you're going to be saving it to the routers or the device's flash memory. You need to make sure that there's enough memory in flash to hold that iOS. If not, you may have to delete the old one. This was a really long chapter. Are you guys still awake and together?
Oh yeah, I'm still awake.
Okay, I'm going to.
There's a lot of good info in there.
Yeah.
Mainly just maintenance stuff like everybody should already be doing if they're doing this.
Yeah, you would think so, huh? I'm going to stop the recording.